Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Today we are in tutorial 13 of Data Science and Machine Learning series. In this session, we are just going to discuss on a recursive function. What is recursive function is that the function call itself is known as recursive function. This is as like a loop, a for loop, like that. Okay, however, sometimes it allows you to write more elegant function that can be achieved with a loop. You can imagine that a function that call itself might end up in an infinite loop. It is true that you can write a recursive function that will help keep on running indefinitely. Here is our program, dear friends. Kindly have a look. And this is our first coding. We have already seen about what is a function, how to call a function, and here it is the function that print the next number. When on receiving the attribute from the user, it just keep on printing. And I just give the function here, and let me just call the function by providing the argument value 5. And see here, dear friends, when I'm just making this functionality, it just keeps on going. Here we just got the kernel restarting. That is, we just received dead kernel. That is, it just keeps on going, but there is no restriction where to stop. Here we are having the recursive function that calling it by itself. And it just keeps on running where to terminate. We are having a struct related to the terminating case. And see here, dear friends, we are having the one to avoid being stuck in an infinite loop. A recursive function will typically have a terminating case, such as a point where the chain of recursive should be stopped or is to be broken. And in our previous example, you would might make it stop once the start parameter is greater than or equal to 7. And here it's so when on just making the same. So here we have included a condition that if that number is greater than or equal to 7, we are just going to stop it by a message that's I am bored. And let me just call this function, and here it is our calling of function. So when on just providing the user value as 5, it just prints the next number, and when it is greater than or equal to 7, it just has a restriction. And it just stops the function that has a recursive. And here it is the one thing, dear friends, whenever we just speak on a recursive function, there is two functions which is very famously called as factorial and Fibonacci. The first one is, let me just have a factorial. See, you can create a factorial function that takes an integer and returns the factorial using both an iterative and recursive approach. So recall that a factorial is a product of all integer up to and equal to the number. So if we just provide 5 factorial, it just makes up to and equal to that of 1, where 5, it just makes the factorial of 5 as n minus 1, and it's 4, and its n minus 1 is 3, and its n minus 1 is 2, and last it's 1. So here let me just make that factorial using iterative function. Here what we have just done is the factorial, each and every function, when it just compute the factorial, here it just makes an iteration, and we are just making that iteration through the for loop. And when on just calling this, kindly have a note of it. The factorial of 5 we just receive as 120. And here we are, dear friends, that the recursion. So note that you can express this expression as n factorial as like n into n minus 1. So for an instant, when I'm just making 5, it's 5 into 4, n minus 1 of 4, and it just goes on till 1. And when I'm just coming to the 0, it has to return as 1. So because anything, if you just multiple by 0, yeah, it returns 0 and the product would just goes on 0. So in that mind, so if it is 0, yeah, it is going to return 1. And see here, dear friends, this is the recursive function. And yeah, when on just making this function on execution, kindly just have a note of it. We are here just given an n factorial, and that factorial, let me just have it as a 5. And next we are having the Fibonacci direct, kindly just have a note of it. So Fibonacci is the one which we just make use of. That is actually it is actually with an iteration, but it is not elegant and should be written with fewer lines of codes. Okay, so you will use recursion to be inefficient, but for a computing an n term of Fibonacci sequence, kindly just have a note of it. So here we are just going to have a Fibonacci value of some n, and that would be, let me just have it as a 7. So in that manner, when on just making 8, so here it is A and B, and it has the summation on the third term. And yeah, second and third term would be have the summation, it would be on the fourth term. And the third and fourth, it would be added up and it just results on the fifth term. So here it just goes. So when on just making that seventh term, we receive the exact summation. And here it's the one, dear friends, kindly just have a note of it. It is the one where we are just making the recursive function. And yeah, let me just execute it. And when on just providing the user a value, and here it is, so the Fibonacci series of the given term, and here we just provided the n term. And yeah, hopefully we have just executed the recursive.